Good morning. I am E. Ilavenil and today we are going to see particle statics 2. So in general, this engineering mechanics can be studied under scalar as well as vector approach. So a scalar is a term which has only a magnitude, whereas vector has both magnitude as well as direction. So force is basically a vector which can be represented by a magnitude value alone as a scalar, along with specifying the direction separately. So though it is a vector, we can represent it as a scalar value where it is essential to indicate the direction. So in vector approach, force is directly expressed as a vector with its magnitude and a direction expressed together in a single expression. So it is expressed through its components along the unit vectors in x, y and z direction, namely I, j and k components. So here the force vector F vector is equal to Fxi plus Fyj plus Fz k. So here the bold letters are used to indicate that they are vectors. There is also another approach that we usually mark it with an arrow on the top of that particular value. So here I thought it is convenient to represent them with bold letters rather than arrows. So we have seen about force. So we will now see about the resultant of forces. So two vectors can be added vectorially. So here force is a vector and that can be added through their components, which is what we call vector addition. So two or more vectors can be added in this fashion. For example, let us take F1 is equal to F1x into I plus F1y into j plus F1z into k, and F2 is equal to F2x into I plus F2y into j plus F2z into k. Then F1 plus F2 vector is given by F1x plus F2x into I plus F1y plus F2y into j plus F1z plus F2z into k, and this is referred to as its resultant. So the net effect of a set of forces can be given by a single resultant of those forces. So here we represent Fx, Fy, Fz, and they are all the force components along that particular axis through which a vector is, or say a force vector is described. So the resultant of any number of forces is their vectorial sum, which can be added as such shown previously or by graphical method or any other method suitable for vectors. So the resultant of two forces of magnitude F1 and F2 with an angle of theta between them is given by an expression resultant R is equal to F1 square plus F2 square minus 2 F1 F2 cos theta whole power 0.5, which means the square root of the same, acting at an angle of alpha, which is given by tan inverse of F2 sin theta by F1 plus F2 cos theta. So this is one special expression or formula applicable for two forces alone. Components of force. So if R is equal to F1 plus F2 plus F3 and so on up to Fn, then F1, F2, F3 and up to Fn are all the components of the resultant, whichever directions they may be. But these types of random directioned components are not so convenient for any usage. So the main components that are along x, y and z directions, which are referred to as I, j and k components, which act along the mutually perpendicular directions, or the components which are studied with greater importance. So as told earlier, there can also be three axes along non-perpendicular directions where the same components can be found out for certain reasons, for certain special studies, but normally they are not comfortable. Principle of transmissibility. So when a force is acting along a point, so we have already told that a force is characterized by a magnitude, a direction and a point of application. So when it is acting along a point, then it can be assumed to act on any point along the line of action of that force. This is called as the principle of transmissibility. So already we discussed force requires a point of application. So here we can change it as line of action. So we say a force is characterized by magnitude, a direction and a line of action. Now we can say. So this is due to the same effect created by the same force of that same magnitude and direction at any point acting upon. Wherever they act, they create the same effect. So here in statics, we say that the effect created is only a reaction, whereas in dynamics, the effect created is a movement along that direction. So whether it is statics or dynamics, the effect created at different points is same. That is throughout engineering mechanics, principle of transmissibility is effective. Reaction. So reaction in particle statics, we study that it is equal and opposite. So here the reaction is equal to the vectorial sum of all the forces applied upon together acting in the opposite direction. So when we say vectorial sum of all the forces, that is resultant. So opposite to that resultant means reaction is equal to minus r, or say minus r vector, or minus of the resultant, or opposite of the resultant. So reaction must also have the same line of action of the resultant. So in 2D, f vector is equal to fxi plus fyj, that z-axis component or j component, k component is 0 here. Here fx is equal to f cos theta and fy is equal to f sin theta. Thus the force vector f vector is equal to f cos theta I plus f sin theta j, which means f1 vector plus f2 vector is given by f1x plus f2x into I plus f1y plus f2y into j, and the resultant is equal to f1 plus f2, which is given by f1 cos theta 1 plus f2 cos theta 2 into I plus f1 sin theta 1 plus f2 sin theta 2 into j. So here the angle is measured usually from the positive x-axis. The same principle and expression can be extended to any number of forces. We can keep on adding the forces. So similarly, reaction and components can also be obtained without the k component. So in 2D force system of particles, we call them as coplanar concurrent system. So when it is particles, it is concurrent system. When it is 2D, it is coplanar system. And 2D study on particles, we call it coplanar concurrent system. So we'll continue along with this in the next coming video. Thank you.